Here's a 3-meter high stone structure. To transport bricks to the top, you could use a stone slab as a ramp to climb up. However, if the structure is raised to 30 meters, stacking slabs layer by layer would be exhausting and highly inefficient. To avoid getting fired by the foreman, you quickly come up with a solution. Install a pulley system at the top of the building, thread a rope through it, tie one end to the bricks, and pull the other end to hoist the bricks to the top. However, this method has 2 fatal flaws. 1, if the load is too heavy, the rope could easily break, and 2, the number of bricks you can lift at once is limited. To improve efficiency, you devise an upgraded solution. You install a hydraulic motor at the top of the building, and build a steel cage at the bottom, connected by a steel cable. By placing the bricks in the cage and activating the motor, the bricks are lifted to the top. Since the bricks are heavy, to reduce the motor's load, you cleverly add a counterweight to the other end of the cable. As the cage rises, the motor pulls the cable, and the counterweight descends, sharing most of the load. However, this setup still has issues. The cage sways unstably in strong winds. To address this, you install 4 guide rails around the cage, and equip the cage with a wheel assembly called a guide shoe, which grips the rails tightly for smooth sliding, ensuring stability. To prevent the cable from aging and snapping over time, you install an ultimate safety device at the bottom of the cage. This device acts like a brake, clamping onto the rails if the cage falls too quickly. For added convenience, you install a control system inside the cage, allowing precise control of the motor's start, stop, and position via buttons. Congratulations, you've invented a simple elevator.